So is language what makes us human? I'm not sure. I don't know. Are we the only ones to have this capacity? We'll see. You know, I'd love to say that I know much about it, but after a long time doing this stuff, I know much less than I thought I did. And the only thing I can do is share with you some impressions of my fairly long career in this business and see where it gets us. And maybe I'll share some new results with you as well. So the traditional story of this business starts in the 19th century. I call it take one, and many of you have heard about it. And this starts with Paul Broca, Carl Wernicke, Norman Geschwind, each of whom contributed some center, you know, in search of probably the first homunculus for something, and this is supposedly the homunculus for language. And the contribution of each of these is some anatomical center and some activity. And the answer these people gave to what language is a collection of activities or modalities. So for Broca, it was speech production. He saw Broca as a phasic. For Wernicke, it was the reception of speech or comprehension. He saw what later became Wernicke's aphasic. And Norman Geschwind's contribution was to point to the angular gyrus as a location of naming. That was the first take on this, and you are invited. I deliberately put this image from Norman Geschwind's 1970 science paper to lure you to seeing the anatomical precision at which this was presented. The second take, and again, this was all lesion-based. Everything was lesion-based at the time. Of course, there were no CTs or imaging devices of that kind, even though Broca himself invented an imaging device that's based on heat, on the measurement of temperature in different parts of the skull. So it was mostly based on clinical observations, which were later codified, as it were, in clinical tests and things of that kind. Later on, a bunch of experimental psychologists joined the fray, and they had heard about Chomsky and the hierarchical grammars that we've just seen. These were Edgar Zurev, Sheila Blumstein, Alfonso Karamazza, the generation of the 70s. And they actually attributed linguistic levels to each of these regions. The idea was that syntax resides in Broca's region, semantics resided in Wernicke's region. Important to say that all these concepts are kind of pre-theoretical. They're not precisely defined in any way that I at least can understand. But this was the claim. In the case of Karamazza and Zurev, it was based on experimental observations of the following kind. You show people a sentence of this type. It's called a relative clause. I think Fitch presented something of that kind before me. Patients fail in pointing to who did what to whom in this kind of sentence, because it's not as if they can guess just from lexical content. They can guess who did what to whom. However, when they have this type of sentence in which world knowledge would indicate that balls don't kick boys, but boys do kick balls, they identify the right doer successfully. So this was the kind of evidence that led to the claim that since you have to rely on syntax in this case and you fail, then syntax resides in Broca's region, because this is what's impaired for you. This is Broca's region on an old scale. So when you look at these early attempts, you can summarize them in saying, first of all, no precise anatomy is offered. It's not more precise than this image shows. The huge amounts of empirical inconsistencies that ensued. People just showed all kinds of things, and then contradictory results followed immediately. And the suggestion, perhaps, is that the right way to go if we want to understand what the neural basis of language is maybe we want to be a little bit more modest, and modest in both the size of the modules that we tend to attribute to abilities, and also the size of the functional, so anatomical modules, I mean, and also the size of the functional modules. So what I'm going to try to do is perhaps advance these conjectures that are very much in line with what I just said, is to say, well, they're small anatomical modules. They're basically the best tool that we currently have is cytoarchitecture, so they're psychoarchitectonically defined. The best tools that we have for the description of functions in the domain of language are linguistically motivated, namely things which are driven by linguistic theory and perhaps by logic. And the idea is that functional anatomy of language and logic should be done by aligning anatomical and functional borders and hoping for the better. And the hope is that we will get small modules. Again, small, it's by the standard of neurocognition. We're not talking about very small networks of neurons. The people who can be credited with being most inspiring to this research program span several millennia here, starting with Aristotle, who invented propositional logic, Frege, who invented predicate logic, Brodmann, who is a representative of a whole era of site architectonic anatomy, and then Noam Chomsky, who provides, he and whatever work that has followed, have provided the theoretical tools with which we analyze structured linguistic behavior. I'm going to dwell, at least at this point, I'm going to dwell very little about anatomy because you've heard quite a lot about that, and those who have been following the histological tradition, this glorious histological tradition, and have made good on the promise are, Katrin Amunds, Karl Zilles, the whole group in Jülich, and many others. I just happen to be lucky to be affiliated with these, so I will be using their maps in order to localize to point to the anatomy at issue. And since Katrin has elaborated quite a lot about it yesterday, I'm not going to talk, at least at this stage, too much about that. And what I want to do is to begin with a 20-second survey of results that come from maybe 2 decades of work, several dissertations on the road, and a lot of related work. And the basic idea is that there are pieces of syntax which are localized in specific parts of neural tissue, and the way you go about them is you test extremely fine contrasts in syntactic structure between sentences. In this case, we're testing the length, as it were. Length here is hierarchically defined, not linearly, but the length of a dependency relation between 2 positions in a sentence. And we contrast them, and once you contrast them properly, it happens to converge on a particular brain region that's asymmetric, namely on the left part of Broca's region. You then localize it with a probabilistic map of the type that Amunds provides. In this case, it's not the type, but it's actually Amunds's map of area 45, the anterior portion of Broca's region. And what you do see is that the longer the dependency relation is, the more activation you get here. You have all kinds of controls that control for other types of syntactic complexity, and you see that you can single out this kind of relationship with fair reliability and consistency. Similar work can be seen that has emanated from the lab of Angela Friederici, who in parallel has done quite a lot of work, mostly on German. And the same kind of result comes out of the work in her lab. So in this case, what you do is German allows us several kinds of permutations in word order in sentences of the type that I have here. So you can either say, today has the father, the boy, the candy presented, or today has the boy, the grandfather, the candy presented. And you can see that the contrast between these two, again, manifests this time a little bit more posteriorly, but roughly in the same region. And moreover, if you increase the number of such operations, which are called syntactic movement, you get even more activation. So you can actually define a parameter, namely the number of such operations, and you can correlate this parameter with signal intensity, and you get very nice correlations, and that's yet another indication that this kind of region, and it's not, I recognize that it's not exactly the same, but this kind of region is, first of all, asymmetric in one's brain, and secondly, represents this specific function and not others. Needless to say, all this work is quite seriously supported. It's quite seriously supported by patient work. Patient work is more difficult to do, but this kind of work is quite seriously supported with that as well. We then have all kinds of lexical relations. I'm sure maybe I'm not doing justice to this kind of work, but the point here is that there are many, many types of lexical relations that can be studied. You can study relations such as frequency in texts and get activations in different places. You can divide things by semantic category, by relatedness, and you get all kinds of activations in your brain, but it's not so clear what these things mean. And the reason it's not so clear what these things mean, first of all, is because for a large part, they stand in stark contrast to clinical observations. This area was pointed to by Norman Geschwind as the area of the mental lexicon, because people who are lesioned here in the angular gyrus and perhaps in parts of the more posterior parts of the superior temporal gyrus tend to have naming problems. So it was pointed to as an area that represents lexical knowledge. And then you get all kinds of different blobs that are represented elsewhere, and it's very difficult to see how you reconcile this consistency. And part of the reason for that, at least so I contend, is that the lack of a theory, like a structured theory that would actually dictate the distinctions with which you work. So let me propose to you something, and this proposal is inspired by Gottlob Frege's famous context principle, which says it's only in the context of a sentence that a word would have any meaning. So perhaps the way to tease apart components of meaning is by looking at it contextually, and this is precisely what formal semanticists do, and they try to break words into their component parts in systematic ways. And let me show you just a couple of examples, because it would lead to our next, to our next chapter. So the two first examples is the very odd flavor that we get from sentences such as A and B. So in A we have, Danny has been playing the piano and he just started playing the piano, or Danny hasn't been playing the piano and he just stopped playing the piano. And if you want to understand why these things sound odd, we might as well divide these sentences, or maybe we can divide these two pieces and call this one P, call this one Q, and then subsequently we call this one not P because it contains a negation, and we call this part R. And now we try to analyze what these things mean and why there is this feeling of oddity. And perhaps there's a piece of lexical meaning that is concealed inside each of these predicates, start and stop, which in fact contains a presupposition that contradicts the preceding sentence. So what does it mean that somebody started something? Well, it actually contains a presupposition, if this person had started something, that at a point in time prior to the point of the report, that person did not do that. So if we say that Danny had just started playing the piano, we presuppose that prior to now he didn't play the piano. And what we did here is we asserted P and Q, but in fact Q presupposes not P. So in fact we derive a contradiction fairly easily from this. I didn't give you the details of how you formally represent presupposition because it's not a course in semantics, but the point of course is that you can easily see how a contradiction is derived here because the presupposition contradicts, and by contradiction one means it's always false, of course. So you derive this contradiction by just looking at this structured meaning. And likewise, what I did with the case of stop is exactly the opposite, namely I asserted not P and R, but R presupposes P. Namely, for stopping something, it requires that you will have done that prior to the moment at which the assertion is, or not the assertion is, yeah, the moment at which the assertion is made, because it said just stopped, okay? So this is how you derive this, and the consequence is that there are hidden meanings, and in particular, there are hidden meanings that contain negations. And this is going to be the rest of this talk is going to focus on negation and its representation. And part of the reason for that might be seen in the following movie. So just listen, it's in Spanish, and I'm sure everybody here speaks Spanish, but since I don't speak Spanish either, I'll translate, or actually the translation is there.
Muchos de los círculos son celestes. Sí.
Can I? Okay. I will do this again. Please notice, the experiment is reading the sentence. The task is verification. What you're required to do is to look at this. This screen contains blue and yellow circles, and she's saying many of the circles are blue. Indeed, there are many circles here. Many is a degree adjective, and the degree is dictated contextually, but by the context, this was quite a few of these. And I want you to notice only the speed at which the patient responded. So what's happening here? 1 second. I don't know why I'm failing. Okay, just...
Muchos de los círculos son celestes. Sí.
That was pretty quick. Look what happens when she asks the same thing, but with few, pocos.
Pocos de los círculos son azules. ¿Más?
She's asking
Pocos
for
de
more.
los círculos son azules. ¿Más? Pocos de los círculos son azules.
So one thing we might want to ask is why we have this contrast, and one possibility, and this work is done in collaboration with several people at the University of Buenos Aires. One possibility is that this woman is a Broca's aphasic, and she's actually affected in Broca's area and its vicinity. We'll come back to that later. And in order to see why there's a difference between many and few that results with this type of problem, we might want to go and look at negation a little bit. So one thing that everybody who studied 5 minutes of logic knows about negation is that it reverses logical entailment. And by entailment, I mean the following: whatever it is that's to the left of the arrow, whenever that is true, then whatever it is to the right of the arrow must be true. Then you would say that something to the left entails whatever it is to the right. And we know that, the set of individuals that ran fast is, of course, always the set of individuals that ran. And in fact, you can see that the sprinters ran fast entails the sprinters ran. If they ran fast, then obviously they ran. And what's clearly obvious to everyone, I hope, is that once you negate the sentence, the direction of entailment is reversed. So if they didn't run, then it follows that they didn't run fast. So this is one kind of property that you see that negations have. There's another thing that negation obviously has is that when it comes in pairs, it preserves truth value. So the way negation is defined is reversing truth value, but when there are two of them, obviously they reverse it back. So if with 2, with 4, we get just formally defined negations to lead to the same truth conditions. And we also get it in language. So in this case, language and logic give you exactly the same result. The second property of negation, which is more something that linguists are more concerned with, is that there are certain expressions called, in this case, negative polarity items, certain expressions which like to be in the presence of negation. This is like a soft way of saying that. And you can see that, like, I have spoken to my mother in weeks, sounds quite odd, but I haven't spoken to my mother in weeks, sounds okay. Same thing with lifting a finger and not lifting a finger. You get this kind of contrast. So keep this in mind, because we're going to use this as a diagnostic for negation in places where negation is absent. In particular, we now look at many versus few. So one thing that you can roughly see, perhaps, is that few may, not exactly, but may be close to not many. It's not exactly so, but we can think about it like that for a second. And the reason we might want to think that few contains a negation is because it passes the same tests in exactly the same way as negation does. Namely, if many of the sprinters ran fast, then it follows that many of them ran. But if few of them ran, it follows that few of them ran fast. So few reverses the direction of entailments. And likewise, few also licenses these odd expressions that are called negative polarity items. Namely, you can say many of the children spoken to their mother in weeks, and that's odd, but few of the children spoken to their mother in weeks, it's okay. And the same thing for lifting a finger. Again, I'm not getting into the detail, but these are quite well-established diagnostics for the presence of negation. The same thing you can see as well when you look at expressions like more than half, and here the relationship between more and less is a little bit better defined than previously, where it was a little vague, so I wrote here less than half is roughly not more than half. Of course, it's imprecise because less than half means not half or more, but let's leave this aside because it's not going to bother the argument later. And we can see that more and less than half are contrasted in exactly the same way as what we previously saw, sentences with and without negation. And the reason I'm interested in that is because this is going to be the bread and butter of the experiments that I'm going to be presenting you with. So the idea would be to test negation without there being overt lexical negation. What we want to do is to look and find a way to extract negation from sentence meaning, but extract the logical operation of negation without it being linked to a specific word that's like no or not. So this is the trick. The trick is to take sentences which have the same meaning in the context, namely in this case, more than half of the circles are blue is equivalent to less than half of the circles are yellow. So we take sentences which are equivalent and they have all the other stuff is the same number of words, structure, whatever you want, not frequency. And these things, not lexical frequency, that is, more is about 3 times as frequent as less, but as I hope to convince you later, frequency will play no role here at all. And what we do is we then ask people, patients, healthy people, to verify these sentences, namely to determine the truth value of the sentence as per the scenario that they see. So I'm telling you first about behavioral work that we did in my lab. My lab was moving, so parts of it were in Canada at McGill and parts of it were done here, mostly with Isabel Deschamps, Galit Agmon, and Jonathan Levinstein. The latter two, I believe, are sitting here. And what we did, it's a little bit difficult to see, is we presented, because I made it a little bit too small, unfortunately, we presented sentences, exactly those that I showed you before, namely more than half of the circles are blue and less than half of the circles are yellow, and all the permutations. We presented these auditorily, and then we showed an image, and subjects had to judge it as fast as they can. We had another manipulation, which is we played with a proportion of the blue-yellow circles, and the reason we played with it is because we wanted to see whether there's an interaction between the way you understand these sentences and analyze them and Weber's law, namely, perception, and the way you do numerical comparisons. That was the purpose. We had an important control, and the control was to give subjects these types of inequalities as those that you see above, namely greater than, lesser than, which have the same kind of matching conditions, except they do not denote what sentences, they don't mean what sentences mean, but rather they relate to, at best, they relate to like comparison between set cardinalities. So we had these controls, which would be a reversal of the relation between set cardinalities and sentences which are much more complicated and in particular contain a negation. And what we find is something that was quite amazing, at least in the beginning, namely there's a cost, time-wise, there's a cost associated with the presence of negation, namely sentences that had less in them, less than half, were much, much slower to be responded to than the sentences with more. And moreover, this has no interaction whatsoever with proportion. You can see there are different proportions. The proportion is close to 1, namely what you see here in the middle. This is like 16 blue and 16 yellow. It's much more difficult than when you have 4 yellow and 16 blue. That's pretty obvious. So the way these curves behave is in keeping with Weber's law. This axis is actually compressed logarithmically, and you can see, and we also measured that the curves that are best approximating this set of data points, in fact, these 2 curves are parallel to one another, okay? So there's no interaction between the effect that we get in anything like numerosity, numerical comparison, and the effect is pretty stable. In fact, you can see it in like almost all these individual subjects. What's quite remarkable, however, is what happens when you look at these inequalities. When you look at them, there's nothing. You get the effects of Weber's law. They're very, very clear. but there's no difference between this guy and that guy. Doesn't matter. And for those of you who are worried about directions of reading or something, with simulated conditions of auditory presentation, namely these things were presented incrementally, there was no way for you to perceive the whole thing or read it backwards or anything like that. It was a tightly controlled study. So this is the result, and what interests us mostly would be the interaction effect between the linguistic effect of negation and the absence thereof in the case of these symbols. So I will call it the net negation effect. And now we did the same thing together with Isabel and several other people, you know, from ULISH, namely Peter Pieperhoff, Francesca Iannili, and Katrin Amunds. We did the same thing inside the magnet. And there, what we looked for is that net negation effect, which once again we replicated, namely we found the same kind of net negation effect. And we also tried to find those net negation effects in the magnet. The reason being, finding that would put a point on the operation of logical negation. That was the idea. And indeed, we found one such area, namely the anterior portion of the left insula. And the next thing, and one thing that's quite remarkable actually, is the fact that there was a pretty solid correlation between the size of the negation effect time-wise and its size in terms of signal intensity for the individuals that are tested. Namely, if you're a fast negator, namely if the interaction effect for you personally is small, then the signal intensity here for you individually would also be small. If you're a quick negator, then the interaction effect, if you're a slow negator, the interaction effect here would be big. So there's like a very clear relationship between these two. Having said that, let me move to the next part, because as Katrin mentioned already yesterday, this was a case in which an activation result, namely the functional domain, has guided the anatomical domain. And the next part was to search for the anatomical correlates for that. So Katrin and her team went out, and let me present to you a new histological area, a new site architectonic area, which is called, they called it ID7, namely the insular disc granular area 7. It's an area which is about 1/10 of each of the language areas, 44 and 45. It would appear as if the mean of the right side is smaller than the left side, but when you actually test it, it's not so, but that's pretty much the case, at least for area 45. So they're fairly, we can't see a reason to think that there's an advantage to the left hemisphere compared to the right hemisphere. It's in the insula. It's not in the language areas. And when you look for, the first thing to do is to look for the match between the functional cluster that we identified via this net negation effect and the anatomical cluster that Katrin and her team identified. The match is actually rather striking. It's really striking. Namely, what you see is that, I mean, here I'm giving you just one measure. We had quite a few, but the measure that you can see here, and I hope you can see the blue and the purple dots here. It's a little bit difficult to see, but you can see that the centers of mass of both clusters, namely the anatomical, histologically defined cluster, and the functional, experimentally defined clusters, the centers of mass are pretty much sitting on one another. So it's fairly close to one another, and it's pretty clear that these things do overlap. And to make a point of that, let me just show you at least a piece of this movie that we made, so you can see that, you know, they don't, first of all, they overlap quite clearly with one another, including those centers of mass. They're also measurements, but this is visualization. And secondly, they're adjacent to, but they don't touch on at all on the language areas themselves. So actually, if I had to say perhaps where language stops and logic begins, I would point to this place. It's not something that we might want to say so easily, but I would stop exactly, I would point exactly at this place. And in my view, it's actually not accidental It's not accidental that this is where you find logical operations, basic logical operations at least, because if one would imagine any path that would be here, it would be a path that starts at the language areas from which output representations go to reasoning and decision-making regions, which are known to be either in area 47 or in the anterior cingulate. And you can imagine that the basic logical operations that exist in semantically constructed representations would be on the road, would be on the way. So if I had to say once again, this is where language stops and logic begins. I want to say a couple of final thoughts about what makes us human, but before saying that, I must say something about this language instinct business. And in fact, when the organizers, my colleagues, my dear colleagues, named it language instinct, I was actually reminded of the first time I heard this, the name of Pinker's book, the language instinct. This was in the very early 90s, before this book came out. And at the time, I thought it was a very clever idea. And the reason I thought about it is because the 1970s and 80s were marred with lots of debate between psychologists, linguists, about many, many things, some of which were reflected in the talk that Fitch gave just before me. And I thought that the way Pinker put it was actually had something conciliatory about it and had a chance to make him into a mediator between these warring camps, because linguists despised psychologists and psychologists hated linguists, and there were all kinds of things which I thought there's much hope, sociologically, there was much hope in the way Pinker positioned this, himself within this group. But when I thought about it later, and in fact, when you look at what's done here, it's very difficult to agree with this. And the reason is the following. If there's anything that's relevant to anything that I've done is the notion of truth. It's critical. I mean, here all the tasks have to do with truth, but more importantly, all the reasoning that underlies the construction of those tasks. And the construction of the stimuli comes from formal semantics and from logic, where truth is critical. So for truth, it's very clear that you need knowledge. I mean, it's just unimaginable that you can determine the truth of anything in this world in the absence of knowledge. And I'm personally not aware of any definition of instinct that includes knowledge. I mean, the idea is, well, there's something innate about instincts, but it certainly doesn't incorporate knowledge. So Pinker's trick, which was quite clever indeed, was to say, well, instincts are innate and language may be innate. But what exactly would remain of language if you strip it out of knowledge? And the answer is pretty much nothing. So having said that, I just want to say one last thing of what makes us human, because again, you know, language is many things, but I doubt it is an instinct. If I had to say what makes us human is something of the following sort, namely, we represent propositional meaning. We must do so in order for us to carry out tasks like the determination of truth. The relation, any philosopher would tell you that the relation between what connects us to the content of propositions is propositional meaning. We know that P, we think that P, we believe, hope, desire, worry that P. So if there's anything to be said about being human, is perhaps to have thoughts, beliefs, and desires that have content. And to the extent that these live at least partially in the insula, maybe to be human is to be in the left anterior insula. Thank you.